For the sake of revision, I think you benefit a lot in understanding, trying to find the difference between an all-node multicast versus a solicited, solicited node multicast. Do some basic research, find the differences between these two multicast addresses with respect to IPv6. Right, subnetting in IPv6, you realize at this level, we actually don't need to subnet, but if we ever need to subnet, this is how we do it. The reason why we don't need to subnet is because we have how many network addresses that are there? 2 to the power of 64. That's a lot. But if we ever need to subnet, it's very easy. Of the 64 bits /64 that we use as the prefix, we have 16 bits which are used for the subnet ID, these 16 bits, right? IPv6 was designed with subnetting in mind. A separate subnet ID field is used to create the subnets. It is the area between the global prefix and the interface ID. So generalizing, we say the prefix is /64, then 64 bits. The prefix is 64 bits, and the interface ID is 64 bits. But in actual fact, the prefix is made up of the global routing prefix plus the subnet ID. So this one, it has 48 bits, and the other one, it has 16 bits. How do we actually subnet? It's very easy. So if you look at this, we have a network. EO, this is an example. 2001 DB8 ACAD /48. That is the global routing prefix that we have. Then to add to that, we have these 16 bits in red. Those numbers in red, those are our 16 bits which are used for the subnet ID. We only have 4 numbers there because representation of those 16 bits is in hexadecimal. Right. So does how do we get my subnets from that? So we get my subnets, I think I once explained this. We get my subnets from this is 4 hexadecimal numbers 0, 0, 0, 0. Those 4 translates to 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It translates to 16 bits. Those 16 bits subnet I did the Apple. Now when the number starts to change, and they 1. That's how we get this 001 because it changes this one. Then you can open a 2 like this. That's how we get 2 here. You can open a 3, that's how we get 3 here. And my subnets increase like that. My subnets are not increase, I actually my bits this side. Then I choose an obatas row. I think I once explained this. To avoid confusion, ukachinja ma-subnets, ukashandisa this 1, 2, 3, 4. Or the first subnet E1, the second subnet E2 like this. This is wrong. Because I am a numbers are shanda up and they hexadecimal. It's not binary. Right. So that is basically how my subnets change. And you realize we have how many networks? 2 to the power of 16 networks. I think this gives a total of this amount of subnets that we can create. I think subnetting with IPv6 at this level, we can say is not very much necessary. But that is how it's done. It is very easy. Unlike variable length subnetting mask IPv4. Right. The example requires 5 subnets as well as for the serial link. Okay, we want to subnet and we get 5 subnets. I think from the ones that are created sure in the previous example, we just take these five. Otenda kuno assigner. Subnetting here is very easy because there is nothing like wasting my IPv6 addresses because I wonder. So you can just take a subnet as it is. You can see subnet iri really 2 to the power 64 addresses. I want this. We don't speak of variable length subnet mask here. So that's why subnetting is very easy with IPv6. Right, router configured with IPv6 subnets. How do we then configure my IPv6 addresses? The same way we configure my version 4 addresses on interfaces is the same way we configure my IPv6 addresses my router interfaces. So unopinda interface, that's the first command. Then IPv6 address with version 4 unongoisa IP address, then unoisa IP address yako subnet mask. With this one, unoisa the IPv6 address and the prefix length /64. That's how you put in IPv6 address. Then after that, you enable exit. Another interface IP address, enable exit. Another one, enable exit. They are leaving out my link local address. I hope they discuss. But this is the GUA. Every interface, every host, if I can say, in a GUA address, ne link local address. So ipapa and assign as well the link local address. The command is still the same. IPv6 address, oyster address yako, then at the end of what link local. I think it was addressed maybe China. Let me see. As you know, this is the end of this. So link local address, unaweza link local address yako here. The command is IPv6 address, then unaweza the link local address, which is usually FE80, one like this. Then at the end of that, unaweza command you can link local, I think. Then that's how you assign the GUA. That's how you also assign the link local address on the interface. Then per Windows host, for example, the same way unoisa IPv4 address ukaenda to the same settings unoona pane IPv6 then ungoisa number yako iyo, and that's how everything works. Right, and this is the end of IPv6. It's a very long I think taitachi 6 videos, probably 5, because mamwe anima 12 minutes, 13 minutes. It's very long, very interesting. It has a lot of theory. It makes them probably why we have my videos like that one day. So, anyways, thank you very much for your time.